Welcome students in this session of Physics New Era channel. In the kinetic theory of gases and radiation chapter, here the most important concept already we saw, that is emissive power. In sequential manner we are going to know about once again the emissive power of a body, and then we have the coefficient of emission, and then absorptive power, and later on we are going to prove some sort of Kirchhoff's law. How it is going to be explained, how the statement that is coefficient of absorption is equal to coefficient of emission, that we are going to prove with the help of this diagram. Before starting, we are going to know some few definitions. We know already this definition, that emissive power. Emissive power is defined as, see, emissive power is denoted by the symbol E. Emissive power of a body is equal to radiant amount of energy falls on the surface of it per unit area per unit time is known as emissive power of a body, a general body or any ordinary body. And later on we are going to know about the coefficient of emission. Obviously we know coefficient means a ratio, and it is a ratio of two quantities. Which are those related to the emission? We have the ratio. Let coefficient of emission, it is denoted by the symbol E, just like this. It is denoted by the capital E. That is means emissive power of a body. That is general body. This is for the general body. General formula. Maybe it is applicable for the black body also, but how it is so, that we are going to know. Emissive power, it is a ratio of, see, it is a ratio of emissive power of ordinary body or a general body to the emissive power of a black body. See how simple it is. It is a ratio of similar quantity, so it doesn't possesses any unit, no unit. We say it is no unit. So we know very well this fact. That is, it is a ratio of emissive power of a ordinary body to the emissive power of a black body. If this ratio it is equal to 1, then we say the body is a perfectly black body. The body is perfectly black body. If E is equal to 0, if E is equal to 0, the body is a reflector. Body is, here the body is perfectly a reflector. Means whatever the we say energy which falls, it will reflect. So it is perfectly a reflector body. If E is, we say, less than 1, that time the body is a ordinary body. And hence we are going to know about all these criteria. We are going to think why it is 1, because we know that whatever may be the, we say, emissive power of a body, totally if it absorbs the total amount of radiant energy, it falls. That means both are equal. That time the ratio is equal to 1. That time the body, it is perfectly black body. If the body, if it is equal to, means E is equal to 0, this coefficient of emission, if it is equal to 0, body is a perfect reflector. And what about this one? If coefficient of emission value is less than 1, then the body is a general or ordinary body. Now, knowing all that, one more definitions I would like to explain, that is absorptive power. Here only I am going to change the fact, that is here instead of this one we have the absorptive power. absorptive power. And this absorptive power is defined as, here instead of emissive means amount of energy emitted per unit area per unit time is known as emissive power, but here it is absorptive means amount of energy absorbed per unit area per unit time is known as absorptive power of that body. Means formula is same, but the sentence it will change. If the emissive power is there, amount of energy emitted. If the absorptive power, amount of energy absorbed per unit area per unit time. Now we are going to know about the Kirchhoff's law using this diagram. I will rub this one. I will explain. Now let us start with the Kirchhoff's law. Before starting, we'll have to know we have the ordinary body A and black body B. Here ordinary body A and black body B, it is suspended with the help of insulating fibers, and total it is an insulating frame in which these two bodies are suspended and are given equal amount of heat. Then what happen exactly? It will never radiate whatever the amount of energy to the atmosphere. It is far more insulated from the surrounding. So these are freely suspended so that there is no conduction of heat through the metal wire. So insulating wire, with the help of insulating wire, it is suspended. See, here it is A, ordinary body. What about B? Black body. B means black body. How simple it is. Black body. And here, if let us consider Q, amount of energy, means this amount of radiant energy falls on A and B, that is ordinary body and black body. Let A is a coefficient of absorption, and E coefficient of emission. This is coefficient of emission. Then we know that QA is nothing but, we say, amount of energy absorbed. By ordinary body, or amount of energy absorbed by a body. Let E is the emissive power of a body. Generally, I am going to write the body means it is ordinary body. What about the EB? This is a emissive power of black body. Now for the ordinary body, here for the ordinary body, rate of emission is equal to rate of absorption. How? Let us explain. Here it is, we say one general body of any size, any shape, and let Q is the radiant amount of energy it falls on the surface of it. Let QA amount of energy it is absorbed. That indicates A is the absorptive power or a coefficient of absorption of ordinary body. So amount of energy it is absorbed in the form of packet or bundle of energy, or we say photons. It is shown just like this. This is the energy which is collected by the ordinary body. After collecting, it will start emitting the energy, because it is not a black body which totally absorbs the total amount of energy. Total amount of energy which falls on the surface of any body, few of those it is reflect, few of those it is absorbed, few of those it transmits. So here it is, whatever the amount of energy it is absorbed, it will release again in the form of energy, bundles, packet of energy, photons we say. So after getting that energy, means whatever may be the energy emitted by this one, it depends upon the absorption of energy which falls on the surface of it. So we say that A is a, we say, coefficient of absorption. So Q upon QA is the general formula for that one. So we know very well that it is Q upon QA. So according to that one, means it is absorptive power of that. It is given by QA upon Q. So QA is equal to Q into A. This is nothing but coefficient of or amount of energy absorbed. So a rate of emission denoted by the symbol E, it is equal to A into Q. A into Q. This is equation number 1. Now what about the black body? For black body, I need to consider same, that is rate of emission is equal to rate of absorption, but that time whatever may be the emissive power, it is totally absorbed by this. This indicates what? Here, if I am going to take this equation as equation number 2 and consider the equation 1 and 2, here if we take the ratio of 1 and 2, here if we take the ratio of equation 1 and 2, equation 1, E is equal to A into Q 1, and EB for the black body, total amount of energy it is absorbed. So equation number 2, dividing 1 by 2. If we divide 1 by 2, E upon EB is equal to A into Q upon Q. That means here Q get cancelled. And what about this? This indicates this is nothing but E, that is coefficient of emission. So it is E, which is given by E is equal to A, means coefficient of absorption is equal to coefficient of emission. Coefficient of absorption is equal to coefficient of emission. That is our aim to prove the Kirchhoff's law. Means this is the statement regarding the Kirchhoff's law. Hence, the Kirchhoff's law states that coefficient of absorption is equal to coefficient of emission at a given temperature, whatever may be the amount of energy which falls on the ordinary body. Few of the we say photons or energy it is absorbed, and then it is emitted equally over all sides. And after some time, we found whatever may be the energy it has, means the temperature, if it is a T1 at initial position and T2 is the temperature of this place, that time after some time T1 temperature is equal to T2 temperature, as whatever may be the amount of energy it is released by the body A to body B, it is absorbed, and both are after some time they are equal. That means, once again, coefficient of absorption means for the given body, coefficient of absorption is equal to coefficient of emission at a given temperature is known as, we say, Kirchhoff's law. That is a statement for the Kirchhoff's law, means at a given temperature coefficient of absorption is equal to coefficient of emission. अब इसको एक बार हिंदी में समझा के लेते हैं. इसको ऐसा कहेंगे हम कि एक ऑर्डिनरी बॉडी हम लेते हैं जिसे हम कहेंगे ए बॉडी और बी बॉडी. इसको हम टेम्परेचर देंगे ये T1. ये टेम्परेचर जो भी रेडिएशन के फॉर्म में हम देंगे तो क्या होगा कि बॉडी इसको जो भी अमाउंट ऑफ एनर्जी उस पर फॉल होंगी वो एब्जॉर्ब कर लेगी. जैसा कि हमने इस पे भी ये प्रयोग करेंगे तो ये समझ में आ जाएगा कि टोटल जो एनर्जी ब्लैक बॉडी पे फॉल हो गई थी उसने वो टोटल एब्जॉर्ब कर ली. लेकिन ये दोनों को हम एक इंसुलेटिंग चेंबर में हम इसको सस्पेंड कर देंगे, जो कंडक्टिंग वायर्स के ये नॉन कंडक्टिंग वायर्स से हम इसको सस्पेंड कर देंगे एक बॉडी में जो कि सराउंडिंग से पूरी तरह से इंसुलेटिंग फ्रेम में है. अब हम कहेंगे कि क्यू क्या है, ये रेडिएंट एनर्जी फॉल्स ऑन ए एंड बी है जो हम टेम्परेचर के फॉर्म में उसको दे रहे हैं. ए कोएफिशिएंट ऑफ एब्जॉर्प्शन है और ई कोएफिशिएंट ऑफ इमिशन है. क्यू ए अमाउंट ऑफ एनर्जी एब्जॉर्ब बाय द बॉडी है. कौन सी बॉडी कंसिडर कर सकते हैं, ब्लैक बॉडी है तो हम इसको क्यू भी कहेंगे, लेकिन यहाँ ये ऑर्डिनरी बॉडी के लिए कहेंगे. ई इमिसिव पावर ऑफ ए बॉडी, जो भी बॉडी पे ऊपर एनर्जी गिरेगी उतनी एनर्जी जितनी ज्यादा एब्जॉर्ब होगी उतनी वो इमिट करेगा. ये सिंपल सा क्राइटेरिया हम इसमें समझाएंगे किर्चॉफ्स लॉ में. ई भी इमिसिव पावर ऑफ ए ब्लैक बॉडी है. जैसे कि पहले हम कंसिडर करेंगे कि ऑर्डिनरी बॉडी जितनी वो एब्जॉर्ब करेगी उतनी वो इमिट करेगी, यानी हम इस पे देखेंगे कि कोएफिशिएंट ऑफ एब्जॉर्प्शन ये किसका रेशो है, क्यू ए अपॉन क्यू का रेशो है. तो इसका रेट ऑफ एब्जॉर्प्शन हम निकाल लेंगे. जैसे कि ये रेट ऑफ एब्जॉर्प्शन है ए इंटू क्यू, उतनी ही बॉडी इमिट करेगी. तो हम ऐसा कहेंगे कि ए इज इक्वल टू ए इंटू क्यू, इक्वेशन 1 बोलेंगे. अब ब्लैक बॉडी के लिए हम कंसिडर करेंगे सी के कैरियर सी के ब्लैक बॉडी. तो यहाँ ये ब्लैक बॉडी के लिए हम कंसिडर करेंगे कि जैसे हम ये ब्लैक बॉडी लेंगे तो यहाँ ब्लैक बॉडी के लिए जितनी एनर्जी उस पर फॉल होंगी उतनी वो एब्जॉर्ब कर लेगा. इसलिए हम इसका रेट ऑफ इमिशन इज इक्वल टू टोटल अमाउंट ऑफ एनर्जी फॉल्स ऑन इट. तो इसको हम इक्वेशन 1-2 कहेंगे. इक्वेशन 1 और 2 को हम डिवाइड करेंगे तो ये हमने ऑलरेडी डिफाइन किया है कि ये रेशो है emissive power of ordinary body to the emissive power of black body, means it is a coefficient of emission to coefficient of absorption. ठीक है, थैंक यू.